Hi, and welcome back to ScottiesTech.Info. I'm Scotty with my co-host Cletus the Tribble. Lately, there have been parts shortages. You can't get computer parts. There are chip shortages. There's even a shortage of frickin' cardboard. So if you're trying to get building supplies, or you have to repair some kind of gizmo, it's very difficult to find things. For example, an alternator. What do you do if your alternator dies? Well, this is a Denso 40 amp alternator from a Kubota riding lawnmower, and it went kaput on me. And so I searched and I went, well, it's a Denso, right? I mean, it's a popular brand. I searched and they said, yeah, a new one is about $200, and sorry, no one has stock. So, right. Now first, it probably helps to understand just a quick recap about how alternators work. It's actually a lot simpler than you might think. So this is a lovely image that I got from starteralternators.co.uk, and it shows basically a teardown of a typical alternator. So of course you have your V-belt pulley, which turns the alternator, and that makes it generate power. But the question is, how does it generate power? Well, it's really not terribly difficult. So what happens is you have a rotor, and the rotor is basically just a spinning coil of copper wire. And when you pass electricity through that rotor, you have a rotating electromagnetic field. Then you have the stator, which is a stationary set of coils of copper wire. And so when you turn the rotor, you have a rotating electromagnetic field. The magnetic lines of force cut through the coils of wire in the stationary stator, and voila, you have actually three-phase alternating current. So essentially, an alternator is just a generator, not unlike the generator that's at the power plant that powers your house. But of course, we're talking about an alternator here, so alternators output DC, direct current, like, to charge the 12-volt battery in your lawnmower or your car or whatever. So there are a couple other key components here. Two electronic components. Those are the diode pack or rectifier and the regulator. Now, the diode pack is pretty simple. It's just a series of diodes, electronic components that convert AC into DC, which is good because you don't want to feed alternating current into a 12-volt car battery, for example. That would be bad. And then you have the regulator, and the regulator's job is to basically control the amount of power that the alternator is spitting out. And the way that it does that is the regulator actually controls essentially the amount of current that's going into the rotor. So the reason this is important is because if you think about, say, a car, when the engine is idling, the alternator is turning at a very low speed, a low RPM. But when you're barreling down the highway, obviously the engine is really, you might be running at like 2,000, 3,000, 4,000 RPM, depending on the car. And of course, that means that the alternator is spinning faster. So the regulator's job is to make sure that the alternator, if it's spinning slowly, it puts out a maximum amount of power to charge the battery. And if the engine, and therefore the alternator, is spinning quickly, it again puts out the proper amount of power. Now there are a couple other parts that I'll talk about in just a second, but that's the basic functioning of an alternator. Now the reason that the regulator is so important is because, the alternator is charging the battery and also providing electrical energy for the 12-volt system in your vehicle, right? So if you don't have a regulator, then what happens is the alternator will start overcharging. It'll start putting out gobs and gobs of power, even when, say, the battery in your vehicle is already full. And that's bad, because if that happens, you get something like this. Generally speaking, if you see greenish sort of powdery, flaky corrosion on the positive battery terminal of your battery, that means that your alternator is overcharging the battery. Because what happens is when the battery starts to get full, the alternator kind of senses this and goes, right, even if the engine is spinning really fast, the regulator in the alternator will say, okay, reduce the amount of juice that the alternator is producing, because we don't want to overcharge and therefore destroy the battery. So this brings us to the failure mode of this particular alternator. What actually happened was I noticed that I had corrosion on both battery terminals, green corrosion on the positive and white on the negative. That was a pretty good indication that the regulator of the alternator was dead and it was not charging appropriately all the time. So I thought, well, I'll just open it up and replace the regulator. And as long as I was replacing the regulator, I may as well also replace the diode pack, because typically the diodes last a little bit longer than the regulator, but I thought, well, I'm taking the whole thing apart, so I may as well replace both. And that's what the parts are in these two boxes here. Right, how do you actually repair your alternator? Let's take a look. So here's the alternator. There you go. We're just gonna take some stuff apart. So the first thing to do is to take the cover off the end of the alternator, and that's going to let us see here. This is the connector, and then of course here you have the actual positive output that goes to your battery. The negative is basically just the metal casing of the alternator. And then this guy here, you can see that is your regulator, and you know which one the regulator is because it's got these big cooling fins on it because it gets kind of hot. And then over here, this weird shaped thing with these little like pill-shaped bumps on it, that's actually your diode pack. So this is the part that's actually converting the AC to DC, and this is the regulator that's making the alternator work all nicely and be happy and blah, blah, blah. So, proper screwdriver is usually good. First we take off these guys. Now it's worth noting here that your alternator may look a little bit different inside, but the basic components are going to be exactly the same. So before you actually order your replacement parts, you're going to have to actually probably take the cover off the end there and kind of poke around and possibly even remove some of the components, the regulator and the diode pack, so that you can see their precise shape, because there are like 1,000,001 different, there are many different types of regulators and diode packs, and yeah. Why are we not coming off? Okay, and this is another part that you want to check. These are, get this, oh my god, these are the brushes. Because the rotor is rotating, you need something to actually convey the current to the rotor to generate the magnetic field, and that's done by these two little spring-loaded brushes. You may also need to replace this if your brushes are worn down. These obviously, like, they've got plenty of life in them, so I didn't worry about replacing that. That's another piece you may want to look at replacing. I think I have to undo these two screws here. Whee! Sorry, Cletus. Didn't mean to wake you up. He was asleep. So there you go. This is the regulator for this particular model. You can see it, get a model number off of it if you need to. And again, you're going to have to search. You can find these parts on sometimes Amazon or eBay or AliExpress, or just search around. Sometimes you may need to order them from even like a different country or something, but usually even if you can't find the whole alternator, you can find the regulator and the diode pack, and they're much cheaper. Like the regulator was like, I think the regulator was like $30 and the diode pack was like $27. So for like $57, I'm basically going to get my alternator back up and running instead of searching and paying $200 for the genuine thing. Next, we want to take the diode pack off, and that's held on by 1, 2, 3, 4 screws. Okay, now in order to get this guy off, you'll notice there are these little wires here. Each of the places where I had the screw, you're going to have to actually gently bend these wires so that you can take this guy off. Pinchies. Where are pinchies? There are pinchies. I'm just going to bend these up. These actual metal wires here are connected to the coils, the output, the AC three-phase output. So now I'm just going to very carefully remove that guy. And there you go. That's your diode pack. And again, be very, very careful because these different diode packs, like these, the wires go kind of from the top straight through down like this. Some of these, instead of the wires going down like that, they come outwards like this. So you may want to actually just take it apart and see if you can find a model number, or at least make sure you know that in 3 dimensions this is what it looks like, so you can order the proper one. So there's our new regulator. And here we have our old and our new diode pack. Now we carefully put this back in, which is going to be a bit tricky. You can see you have the wires sticking up and you have to may help to use a pair of flat pliers and kind of straighten those wires just to make your life easier. I'm going to feed that over, get each of those wires in there. That one's in. That one's in. That one's in. This one's being a little problematic. Oh, there he goes. So then once you've fitted the new diode pack, you have to take these wires and curl them down again so that they make contact with the screws. It's a bit fiddly. And again, you might think that, like, oh my god, this is too complicated, I can never do this. Yeah, that's exactly what I thought, and yet here I am doing it. So, you just have to be a little bit adventurous. Of course, there's always the internet. They'll always tell you how to do everything. Now we can put the screws back on. Which is going to pinch down those wires there. We just snug it down. Okay, so that's the new diode pack. Now we want to put our regulator back on here, and we're going to put that in there, and we have to fit this guy back in. He goes, I believe, on top, so I have to figure out how to put this thing back together now. Yeah, that was That was smart. And getting this in here is a little bit tricky because you have to push the spring-loaded brushes in and kind of squish it down in there. And we've got all our screws, so now we can... Did I do something stupid? I probably did something stupid. All right, something went wrong. Ah, I see what went wrong. I used the wrong screw in the wrong place. So it helps to actually pay attention to what screw you put where, because some of them are longer and some of them are shorter. Yeah. And there you go. We're done. We're all hooked up. So now we can put our cover back on. So there you have it. We have replaced the diode pack and the regulator, and our alternator is ready to go. So let's test her out. Okay, so this is our test setup to test the alternator. I've got the alternator mounted here on a vise. It looks really complicated. It's not. Basically, this is the circuit. You have the positive output of the alternator, obviously going to the battery. The negative cable of the battery goes to the housing of the alternator, and then there are two other wires in the case of my alternator. One is labeled IG and the other is L. IG is basically 12 volts going from the battery to the IG terminal. That's what actually provides power to the regulator, which provides juice to the rotor so that the alternator will generate electricity. And the L line is simply hooked to a light bulb, and that light bulb, the other side of it, is connected to the positive terminal. The idea being that's the charge light on your dashboard. So when you turn the ignition on, which I will simulate by connecting the negative terminal of the battery to the housing of the alternator, the light will go on. When the alternator starts producing juice, the light bulb will go out. And I have a voltage meter and a current meter here so we can see what things look like. If I turn the meters on, okay, so you can see we have no current and about 12.31 volts. And now I'm going to hook up the negative terminal of the battery to the alternator housing. So now, okay, now we're putting a load on the battery, so the voltage dropped to 12 volts. Current is pretty small. Now I'm going to use this big guy, which is more powerful than the maximum power output of the alternator, to turn it, and we should see something fun happen. As you can see, the voltage went up and the current also went, so that means, ta-da, we fixed it. And there you go, that's all there is to it. Instead of spending 200 bucks on a whole brand new alternator, you can just spend like 50 bucks, get a couple components, swap them out, and Bob's your uncle. It's worth noting that you also want to check the bearings. The bearings are two other key components. Obviously, the rotating rotor ain't going to rotate if the bearings are shot. This particular mower and alternator are 10 years old, 800 and some hours, something like that. And the bearings seem fine, the brushes seem fine, the windings seem fine. You just use some compressed air, clean them off. And if everything else looks good, and especially if you're having like an overcharging condition, most likely it's the regulator. If you can, you may as well replace the diode pack too. It costs hardly any money. It requires just a little bit of patience, and as you saw with the screw mix-up, Just a little bit of patience and elbow grease, and you can take your dead alternator and revive it for way less money. For more techie tips, see ScottiesTech.Info. Thanks for watching. See you next time.